Here are the answers for the day one bell work. How is the equilibrium position of this reaction affected by the following changes? And all of the questions refer to this reaction right here. Notice that this is a reversible reaction indicated by the double arrow. Sulfur dioxide combines with oxygen to produce sulfur trioxide and heat. But at the same time, when the sulfur trioxide is being heated, it will decompose to make the sulfur dioxide plus oxygen. The forward reaction is a combination reaction. The reverse reaction is a decomposition reaction. To say that the reaction is in equilibrium means that the rate of the forward reaction is equal to the rate of the reverse reaction. Equilibrium position is referring to the concentrations, or another way to think of it, the amounts of the substances that are involved when the reaction is in equilibrium. When something about this system is changed, that will affect the equilibrium position, causing the forward reaction to occur at a faster rate, or perhaps causing the reverse reaction to occur at a faster rate. Question A. What happens if temperature is lowered? This will cause the equilibrium position to shift to the right, so that more heat is produced to compensate for the change where temperature was lowered. In words, we call that favoring the products. The forward reaction occurs at a greater rate or greater speed so that more of the products are created, in this case, so that more heat is created, which overcomes the stressor of lowering the temperature. Question B. How is the equilibrium position affected if the pressure is decreased? The equilibrium position will shift towards the left, meaning the reverse reaction will occur at a faster rate than the forward reaction. In words, we say that favors the reactants. Here's the reason why that happens. This equation shows that the forward reaction uses 2 plus 1 or 3 molecules to combine together to make 2 sulfur trioxide molecules. But the reverse reaction uses 2 sulfur trioxide molecules to decompose, creating a total of 3 molecules on this side. Favoring the reactants means making more of these molecules on the left side of the arrow. If more molecules are produced in the system, then there are more particles to collide, which will offset the fact that pressure was decreased. Question C. What about removing oxygen? If oxygen is removed, then think about how can it be replaced? If the reverse reaction occurs at a faster rate than the forward reaction, the reverse reaction creates sulfur dioxide and oxygen. So if oxygen is taken away from the system, we could replace that lost oxygen if we get the reverse reaction to happen faster than the forward reaction. We say that this favors the reactants. Finally, question D. What about if sulfur trioxide is added? Here's sulfur trioxide on the right side of the arrow. What if more sulfur trioxide is added into the system? What's going to happen to the equilibrium position? It will shift to the left. If the reverse reaction happens at a faster rate than the forward reaction, then that excess sulfur trioxide that has been added to the system will decompose, creating sulfur dioxide plus oxygen. In words, we say that it favors the reactants. To answer all of these questions about equilibrium position, think about how you can overcome whatever the change is that's been made to the system. Do you accommodate that change by shifting the arrow to the left or by shifting the arrow to the right? Which reaction needs to occur at a faster rate, the forward reaction or the reverse reaction?